And we're live, so good morning, good afternoon, good evening, whatever time it is for you. I'd like to welcome you to a presentation by the Storage Networking Industry Association Cloud Storage Technologies Initiative. Cloud analytics drives airplanes as a service business. My name is Jim Pfister. I'll be the moderator today, and I'll be doing a little bit of talking as well. I'm an independent contractor for SNEA, and then I'm also principal at my own consulting company, The Decision Place. We hope to have Glenn Bowden, who's the CTO of the AI and data practice at Hewlett-Packard Enterprise. Glenn's a little delayed right now with an issue, and we hope to get him in after we resolve the technical difficulties. But I do want to say, I like Glenn, I like working with him, but it's very rare that as a moderator that you get to work with a good friend and a person whose entire career that you followed. So say hi, Ben. I'd like to introduce you to Ben Howard, the CTO of ConnectAir, and a good friend of mine. So Ben, why don't you talk a little bit about yourself real fast?
Yeah. Hey, Jim. Thanks for having me on. It's great to be here and excited to talk about both my career and where it's taken me. Just a little bit of background. My first professional job out of school was at Intel, and Jim was the guy who hired me. And super thankful for that, and really opened some doors for me that were neat. Worked for Intel for a couple of years, and then started looking over my shoulder and seeing the drone market pick up a little bit. Left Intel to co-found a drone company, and learned a lot of lessons through that process of co-founding a company, of struggling with product, struggling with engineering, struggling to go from 0 to 1 and actually make something interesting. From there, moved on to another precision agriculture and analytics company that was doing a lot of the machine learning and image processing that kind of got my feet wet at Intel. From there, stepped on to another analytics and data company, this time doing personal aviation. So making it possible for the average public to pull a phone out of their pockets, pick A to B routes on their favorite airports, and then fly private to wherever they want to go. So some really neat different things that I've got to work with that all started at Intel.
Yeah. So I call Ben a serial CTO. So we'll be talking about probably all those things and maybe a few other things. First, let me give you a little bit of detail for those of you observing on the Bright Talk. I've watched several Bright Talks in that interface. You can see you have a screen, and then you have a couple of buttons underneath that. One of those will allow you to download the presentation, or you can go to the SNEA Educational Library after this presentation and you can download because this entire talk will be posted there. You do have the ability also to make this full screen, and note also that there is an ask a question thing under there. We certainly encourage all of you to ask questions and to make this more of a conversational dialogue. We're going to have a great conversation today about business analytics and how you can turn that into companies like an airplane as a service. So what about SNEA? SNEA at a glance, we're 180 industry-leading organizations. We have over 2,300 active contributing members, and we reach out to over 50,000 IT professionals worldwide. We in the Cloud Storage Technologies Initiative, we focus on educating vendors on cloud storage, data services, and orchestration, but really what's going on with the cloud and what's going on with analytics and new technologies. We support and promote the business architectures and models that SNEA standardizes. We want to help you understand some of the different requirements, and we want to help everybody understand how you can take all the efficiencies of being in the cloud and turn that into opportunities for your business. And again, we'll be talking about quite a bit of that today. And then we want to be able to collaborate with other industry associations. We'll work with working groups inside of SNEA as well as other standards bodies in order to be able to promote new technologies. Just so you know, neither Ben nor I are lawyers. I did take an engineering law class once. We won't talk about my grade in there. Ben, I don't know if they made you take law or not, but we're not here to provide legal notice. Glenn, if he manages to make it on, also is not a lawyer. We're giving this as our opinions and as technical experts, but we're not trying to represent any legal opinions in this. So there's no warranties expressed or implied. So we're going to talk a little bit about some of the things that Glenn wanted to talk about. And Ben, I'll start asking you a question to start. So talk to me about the difference between capturing data and capturing data for machine learning and artificial intelligence. What's the real differentiation to you?
With a lot of data capture, there's the inherent messiness of real data capture, right? If you're not getting sanitized data, you often have everything from misspelled words to poorly tagged images, and a lot of that causes issues down the road if you're going to try to use it as a machine learning deck. And so, purposely capturing data in a way that that it's sanitized or very carefully focused on what you want to go do. The machine learning right now, a lot of it still really is brittle and sensitive to to mistagged data and things like that. And so that kind of whole garbage in, garbage out kind of idea, I think really ought to be applied to everything. That if you expect even your sales team to do something interesting with data you're pulling from Salesforce, it's again, if things are misspelled in there and you can't find customers, you can't find correlation between, I don't know, spending and return on investment and things like that. All of your data is for nothing.
Yeah, so it's interesting the amount of time you need to spend in terms of, Glenn says that here is data processing, and I think what he really means is, is basically data cleaning. You need to make sure it's clean in order to be able to get that value of reaction out of the analytics. And that really pushes us to getting more to a predictive or a prescriptive analytics space. It's really easy to say, hey, I've got data and I can pull down that data and it'll look and give me a sales report, or it'll tell me when I need to do a shutdown. But it's another thing to actually start to anticipate changes in the marketplace and or changes in your environment and what that's going to do. And that really comes to an optimized outcome. Ben, why don't you tell me a little bit about some of the things that you've learned in this area?
Yeah, and it's I think the thing that's interesting here is that switch over from, I guess, not trusting the machine to trusting the machine. And so on one side of the page, you've got a human operator has that intelligence to say, okay, hey, look, if this thing's been up for 48 hours, it needs to get shut down to go through its reboot cycle, or this part typically fails after this many days or this many hours, and so we ought to replace it before it happens. And so there's some really tried and true, especially in aviation, right? Like this propeller part only lasts for X number of hours. This engine has to get rebuilt every 2,000 hours and things like that. And so there's a lot of industries, especially manufacturing, who understands the lifetime of their tools. But it's really hard to make that jump to the other side where you're letting analytics decide, hey, this part is about to wear out, even though it's technically 50 hours short of its expected lifetime. That everything from vibration data to other performance data may give you indications that this part may fail, or that you need to go through a reboot process or something with a server that's running. And it's tough to let go as a good human operator. You have that gut feel, but we're definitely approaching that, especially at KinectAir, right, where we want to do performance-based maintenance so that we're ahead of that curve and things don't break on us. That we catch it earlier because we can trust the machine to catch it and see those indications coming that that we have a problem.
Mm-hmm. Well, actually, let me use that to really talk a little bit about some of the things that you learned in the past and some of the things I watched you do in terms of the preventative analytics. That was really a large portion of Honeycomb, which was your first startup. So let me see if I can describe it, and then you can fix anything I get wrong. At Honeycomb, your goal was to create a self-piloted drone that would overfly farm fields and would take thousands of images. You would then use image analytics to stitch those together to create a multi-terabyte image, and then you'd actually do image processing to look, especially in the ultraviolet space, to look for preventative things that the farmers could be doing in the field. Did I get that right?
Yeah. And so KinectAir, Honeycomb did all of the data collection side of it. Where we really did fall short was the analytics side of it. That what happened to us was we could collect all that data, we could sanitize it and remove everything from sun reflections to clouds and things like that really do screw up your image processing. But what we didn't do was that next step of here's the analysis and here's the actual action you need to take. And so we didn't deliver all of the value that we should have. And so as a company, we absolutely succeeded at delivering world-class data. What we didn't do was take that next step and say, here's what you need to spray differently, to harvest differently, to plant differently. Here's the actual action you need to take. And so that was kind of that next company that I moved on to, was that next generation of analytics that really crunched that data down into actions that you could really go take. And it was built on the backbone of trusting that, trusting the image processing going into it, that we had removed, reflections and clouds and tractors and fields and things like that can screw up your analytics, so that we could go do that next step.
So to some degree, data without analytics is frankly just data, and it's sitting there at rest. So why don't you talk a little bit about the work that you did at rest, and I'll kind of work through this build of Glenn's, but talk a little bit about what you did at rest and how you started to introduce analytics into image data.
Yeah, when I joined the company, they had a lot of the same struggles that Honeycomb did, in the sense that they were collecting all this data, but really didn't have the expertise or the authority to take that action with it. And so we put together a collection of farm agronomists who had that legitimate expertise in how plants grow and what they look like and things like that. And then we collected data, purposefully collected data to catch these issues. So to look for lesions on leaves, diseases on leaves, to look for specific pests and things like that. And then used our agronomists to tag all of that data that we had to sanitize it and make sense of it. And then that became the basis for our machine learning algorithms to detect these things and also to predict it, right? So given that we have a bug pest population in part of this part of the field, what's the chance that it spreads over the course of the next couple of days, and which direction is going to spread? So there's existing models for a lot of those that come from the agronomy world. And then we digitize those and kind of went that full step from the robotics level of data collection all the way out to image processing, and then all the way out to action. So actually turn a sprayer on and off as that sprayer sees those bugs, as the sprayer sees diseases on leaves and things like that. And so we had to bridge that entire process of the capture and sanitization, the tagging, the analytics on top of it, and then the actual application, and not just the application of it, but again, the visual interface to show where you had sprayed, to show where you had harvested, to show the impact of your entire process. And so that full loop really was what delivered value to them.
Mm-hmm. So really, as I look at Glenn's description here of traditional data for analytics, and you start to look at some of the edge data sources, those edge data sources are also probably opportunities for edge manipulation. So not only am I collecting data, but I'm actually also acting on it.
And I think along that line, that instant response is huge, especially in the precision ag industry. Being able to collect data at a camera on the front of the tractor and then turn the sprayer at the back of the tractor on immediately, that closes a loop in ways that you just can't close it if you do it the slower way, where you capture all the data, process it overnight, and then go back out and act on it. That's too slow for precision ag and for a lot of other industries, right? And so having that onboard processing to capture, process, do that analysis on board and actually take that action all in one shot, that ends up shortcutting a lot of the archival and the storage side of things in a way that now needs to have cloud access, so that you can hit that instantly in the field with everything from 5G to Wi-Fi in the field and things like that. To have that analysis done instantly, it is huge.
So when seconds count, your data decision might be hours away.
Yeah, if you're not doing it on board. And so that blend of edge processing and then having that backup of cloud storage available, right? So as we crunch data, we can save metadata there. As we run different analysis, we can switch out what algorithms running, do over-the-air updates and things like that. And if you detect a problem, catch it early on. So having that cloud access again to that data source of expected results and things like that to really fact check that as you're running it is super neat.
So you went from making decisions on whether the bug on the leaf was a good bug or a bad bug. And now you're getting into understanding how to collect your data, how to detect and make those decisions, and how to do that action plan. And you're taking it to an entirely different model. So let me pause right here. Talk to me about ConnectAir and what is it that you're doing, and what is it that gets you so excited about this as an industry?
Yeah, it's a neat industry, and it's got a lot of parallels to precision agriculture in the sense that there's a lot of legacy to it, right? So agriculture, we've been doing it essentially the same way since we put tractors in the field, 100 years ago now. And aviation has evolved somewhat, but again, we're still flying aircraft that the engines and airframes were designed, 60 years ago, some of them. And so there's, again, a lot of legacy there and a lot of really process-driven, old process-driven kinds of applications. So aviation in particular, they use a lot of software in different places. So, they may have software for tracking pilot schedules. They've got software for tracking maintenance of aircraft. They've got software for dispatch and other things like that. But really, almost all of aviation today still has a person sitting in a mouse and keyboard who's that intelligence behind, that man behind the curtain in The Wizard of Oz, right? And so what we want to do with ConnectAir is to take that operator out and let AI do that job in the middle. So instead of that request coming in for, hey, I'd like to do a flight from A to B, that comes in and instead of a person interpreting it and saying, okay, here's the aircraft I've got available in my fleet, here's the pilots who've got qualifications to go do this flight, and putting all that together, letting software make that choice in a way that really opens up the number of chess moves that we can think ahead. So a human operator, two or three chess moves out, that's about all that you can think through. But with the software operator, it can think through, okay, if I move this flight at a loss, I may have my fleet in a better position for the next 3 moves, and that actually makes me money. And so that's something novel that software can do that human operators really can't. And so all of this drive is to make aviation more efficient and more accessible to people. That there's a lot of people out there who would love to fly private, especially now, and just don't know that this is an option or can't afford it the way it is today. And so for us, really democratizing private aviation in a way that's never been done before. That for scale, the private aviation isn't for the 1%, it's for the 0.1% today. And we want to take that down to the point where folks with regular engineering jobs can afford to go do this from time to time. And it's not going to replace Alaska. It's not going to replace Southwest. What it is going to do is give you that option for, okay, I want to go visit both sets of grandparents this year for Christmas. This is a way you can do that flight. Or, hey, this is a bachelor party weekend. Let's go play golf somewhere. And again, this is a way you can do that flight in ways that you just couldn't do otherwise. So some really neat opportunities there in the sense that bringing this to a whole new demographic of people who would love to be able to do this and would love to be able to access the things that this kind of aviation opens.
Well, and what I found that was really interesting when we were discussing this is it really takes in a lot more than just the flight. There's where's the person located?
Yep.
There's what's the weather? Where is there congestion in the air? What's going on with the other airlines? I mean, to some degree, the only time that you ever worry about what's going on with the other airline from your flight is when your flight gets canceled. But you actually see opportunities in terms of what's going on with the airlines prior to the cancellation or prior to the move to be able to understand things. What I'm going to do here is I'm going to end the slides and I'm going to go to our beautiful faces here so that you online have something else to look at. Certainly feel free to join the conversation and ask questions. I've got a couple on my own. And so let me start on that first one, Ben. What is it that you're looking at when you look at another airline, when you're looking at an Alaska or a United? What are you gleaning from them, and what decisions does that allow the software to make for you?
Yeah, that our data picture really is a patchwork quilt of all of the different data sources available. Everything from public FAA data to weather data to customer real customer demand through our app and things like that. But what that does for us is create a picture that potentially we see a disruption happening let's suppose San Francisco has got fog and we know it's going to back up flights there. And so, there's going to be a bunch of people stuck there who need to leave San Francisco to get home, to get other places. And that gives us an opportunity for ConnectAir to purposefully go station an aircraft at San Carlos, half an hour south, that doesn't have fog. And so, we see that disruption happen in commercial, and there's somebody sitting in San Francisco who says, look, I just want to leave and I don't care what it costs. And so that opens a door for us. And the same thing on weather disruptions, like going to Vail or going somewhere else in Colorado to go skiing. If we know there's going to be a snowstorm, I have to budget my fleet time carefully so that I don't get an aircraft stuck there. And if somebody does want to go fly because they're a big powder skier or something like that, I have to understand the risk of getting that aircraft, of getting part of my fleet stuck. And so what does that do to my cost of operation if that aircraft is out of service for a couple of days in a snowstorm? And so I have to bake that into the customer price, in the sense that there's let's suppose there's a 10% chance the aircraft gets stuck. And so what's that cost to me? What's my expected value there? And so doing that for all of the different, iterations of chess moves that we've got. So imagine again an example where somebody wants to fly from LA to Las Vegas. I need the aircraft back in LA to go do my next flight. And so do I fly that aircraft empty on my own dime, or do I charge the customer for it? Or do I say, okay, there's an 80% chance that somebody wants to fly back from LA, from Las Vegas to LA on the same day in a time window that'll work for me. And so I can take that probabilistic idea and say, I'll share that risk with the customer and cut them a 60% discount basically, and say, I'll take that risk to me that I can find somebody to take that flight home. And so a lot of those kinds of things around demand, around the weather events, around including even like social events, right? So back in the pre-pandemic days, sports events and things like that change that ebb and flow of where people want to be in really dynamic ways that the existing aviation that United and American don't really handle. Either the plane's full or it's not. But with ConnectAir, the plane only moves if people want to move it. And so us, purposefully being really sensitive to that kind of thing, to move our fleet, to rebalance, to really take advantage of that.
Mm-hmm. And this gives you a couple of advantages, because one, you can actually build your own fleet, and I know you're doing that. But that also gives you the opportunity to then to drive more of a gig fleet as well, correct?
Yeah. Yeah, so our pilots will be a combination of full-time employees and gig economy, and in the sense that we need to have folks who are properly trained, properly certified, that we're not doing it the Uber way where anybody with a license can show up. Aviation takes a lot more trust than that, I guess. And so we'll have that, all of the training contracts and things like that will be full-time on our books. But then the pilots will be able to put in shifts for us and say, hey, look, I'll do 5 days this month, or I'll do 10 days this month, and put those under our books to be available captains for different flights.
Mm-hmm. That's almost like a sensor input. You're actually having people saying, okay, I want to make the airplane and myself available, or I want to take it off, and there's going to be some predictive analytics around that. This lady always is ready on the weekends to go flying, and so this is a great opportunity for me to start saying, well, where can I stage her potentially in the airplane to make a decision.
Yeah, and so that's the demand side of things, right? So like if we know that there's a whole bunch of people searching for a flight from, San Carlos to Tahoe, but nobody's actually bid yet, there's a really good chance that somebody in that category is going to want to go do that flight. So let's go ahead and move the aircraft now, and then I'll take the risk to essentially schedule it myself, and then say, okay, who wants this? And so there's things like that. We can be proactive about it. And there's also analytics around, let's suppose we know you as a customer are always late. I have to bake in an extra hour to any of your flight scheduling so that I don't upset the next customer who needs that aircraft. And so, that kind of stuff we can do both on the customer side of things, on the demand side of things, and then, other things like weather, and being proactive about it, right? So that we actually deliver that experience that people expect out of it.
Mm-hmm. Well, and the flexibility really comes from, again, we were talking about some of the different data sources that you have. One of the data sources you're working with is true origin and true destination. When I'm booking on a normal airline, my choice is a 3-letter airport 40 minutes away from me, versus when I'm booking on ConnectAir, you're looking at where I live, and you're actually looking at the permutation of all the different airports that you could do. So there might be a commercial airport 40 minutes away from me, and it's a very nice commercial airport, but there's also a landing strip that'll take your plane within 5 minutes walk of my house.
Yeah, for you, you could almost walk to the Sun River Airport, right? And so,
right.
For us, what we want to do is exactly like you said, actually have the door to door is part of our picture. So what it does is give ConnectAir the option to do your ride share to the appropriate airport. So if we have an aircraft that's in an airport that's 10 minutes further away from your house, but the aircraft is already there, it's going to be substantially cheaper than moving it to the other airport that's on the other side of the city. And so we have that flexibility to do the right thing for the customer, in the sense that, okay, we'll buy a 10-minute ride share for you to get you where the aircraft is, or potentially put you on at an airport that has a better terminal experience, a better private terminal experience for you. So some of the airports have a big tin shed is the whole airport, and so there's other ones where they've got beautiful Atlantic aviation terminals that are a pleasure to be at, right? And so some things like that give us flexibility around putting you in the right place as we go from A to B. And then the same thing on the destination side. So again, if we land at an airport that I know I'm going to have demand from, I'm going to discount that flight to you because I have a better shot at getting that aircraft moving again. And so again, I'll happily buy you a 5 more minutes of ride share to your house to make that happen. And you may save thousands of dollars doing it over the course of, several flights and places. And so some really neat options there that letting, again, the machine have that flexibility to make those choices for people really can do some neat things for you as a customer.
Yeah. So you're describing to me the difference between predictive and prescriptive analytics. So predictive analytics would say, I anticipate based on weather that I got to put an airplane in San Carlos. Prescriptive is I'm going to change the behavior of my passengers to some level to get them to say, I'm willing to be flexible because that's going to save me money, or I'm going to be inflexible and that's going to cost me more. But you're basically you're trying to modify a behavior in order to maximize your profit. So it could be, again, you want me to go 20 minutes to Bend Airport as opposed to driving 5 minutes to Sun River Airport because you know that you might be able to pick up an additional passenger in Bend.
Yep. Yeah, and so this is again where I give you that choice, where I'm economically indifferent to it. That software has figured out here's the cost of these two things, and I'm equally happy. And you, the customer, say, hey, look, I don't want to drive to Bend. That's your choice, and I've priced them in a way that I'm happy either way, because I've figured out that risk. I've figured out that the probabilistic gamble of moving something, and so I can purposefully move that knob back and forth depending on whether I want to influence you to move, to do demand augmentation, in the sense that I have demand, you want to move somewhere, and I can say, hey, maybe you want to move here instead of there, and help you help me. And so the same will happen. Really, what we're doing is the pricing engine, right? Of like, that's how you influence demand, is moving those prices up and down, potentially in the user interface, doing things like highlighting routes that we know are going to be cheaper, highlighting airports that may have a better experience, that the terminal may have more amenities or rental cars and things like that available. And so really helping you find the experience that you expect out of it. And then again, like I said, purposefully influencing things to make your flight more efficient, to make your flight more economic for both of us, right? If I can get you to land at an airport that has cheaper fuel, it's going to be better for you and better for me. And so, how do I show that to you? Probably through price. And potentially other icons that help make some of those decisions.
Well, and you use the word that I wanted to use, and so actually talk about it. So a lot of the model that you're using, you're not necessarily using an image analytics or something like that. You're actually looking at more of a gambling scheme or a Monte Carlo simulation to really make your decisions. So what you're doing is betting your company on making the right choices, both predictive and prescriptive. Correct?
Yeah, a whole bunch of Monte Carlo modeling is going to run in the background, and I've already done a bunch of it. It's been super neat to see the way that's played out. That our our real demand through our demo app has really shown that our Monte Carlo modeling was right. And to be clear, it's no crystal ball that can tell you exactly, here's what's going to happen in the future. What we use it more for is an order of magnitude kind of decision making, like that. Do we turn this knob up or down, or how does that knob affect the way things are going to play out? So if you go through a Monte Carlo model and all of those scenarios end with you losing money, it's a bad plan. And so, the same thing on the flip side, where if all of these scenarios seem promising, we're equally happy to try any of those scenarios, including flight modeling, things like that, where in any of the routes that are available, we equally happy on those. And the same thing goes for return legs. So again, that empty flight from B back to A, I don't have to take B back to A necessarily. If any combination of B to C to D actually gets me closer to home, what is that? What is my expected value there? And then using Monte Carlo modeling to say, how likely am I to get one or more of these hops that takes me home? And here's the expected value of these trips. And then purposely using the kind of the hotel tonight idea of discounting down to my actual cost to move the metal to get folks to hop on these flights and go for it.
Well, there's that, but then there's also raising as well. So to some degree, you're never going to say no to a flight. You're just going to continue to raise the price. So at some point or another, if I'm really desperate to get from one place to another, and I'll pay whatever it takes, you can build into your model, oh, okay, well, I guess I can fly them for that.
Yeah, and that's kind of the pricing engine, right? Of like, if you want to do a flight 3 weeks from now, there's a really good chance that I'll find bits and pieces of other flights to fill in the cracks around, right? That I can make that efficient because I've got time. If you want to do a flight that's an hour from now, I can't make it go any other way. It's brute force, right? So like, I just have to I have to eat the cost of all of the other moving that I'm going to have to do. And so, that gets passed on directly to you as the customer, because the pricing engine is playing through all of those scenarios of what's it cost to fuel the plane? What's it cost to call up a pilot who's on standby? What's it cost to shuffle 3 other aircraft to meet existing demand that I've already paid for? And here's the actual cost to go do this flight. And again, you're exactly right that don't want to say no to it, but it's going to be expensive if you want to go right now to the middle of nowhere, Nevada. That there's that kind of stuff. We can figure out that actual price instead of saying no. Just say, hey, here's what it is. And again, I'm happy either way. That I'll make money because software has figured out here's my actual cost of operation to serve that flight.
So that's an interesting lesson for those people listening. I mean, one of the things that AI really gives you the opportunity to do, if you're doing the right things, is always decide yes. Now you have to put all the parameters in place, and you have to be able to say, well, I'm making yes, and I'm making that yes decision at a cost. But if my career started in customer support, and I always used to say, roll 1, the customer is always right, but roll 2, I know more. And so from that perspective, you're getting back to that from a customer care standpoint. The customer is right. They want to make that decision. I know enough that I can, to use the old Wilson term, negotiate to yes, right, for both myself and for my customer. And that's something that analytics does for you. How did you conceptualize that based on where you're going? I mean, I can remember the conversations over a beverage when you were starting this up. But what got you from, hey, I can decide what a bug looks like, to I can actually always serve a customer?
Yeah, I've said it a lot of times about software that it really is a toolbox. And that was my favorite part about going to school, was that I got a toolbox I could take anywhere and do anything with. And so I've jumped from doing image processing at Intel to designing an airfoil for a UAV to finding bugs in the field to moving aircraft and serving customers. And software as a toolbox, I take my wrenches and hammers out, and I can go make anything with it. And so I've really always enjoyed that part of it. And I think the thing that I'm looking forward to the most at ConnectAir is the more customer centric, right? Where my past couple of gigs have been really enterprise focused, or really business to business, in the sense that a couple of big businesses were most of our customer base, and so we just did exactly what they asked for. Whereas at ConnectAir, there's an opportunity to really fit our customers as an individual, and really really polish a piece of work, in the sense that before, the big, billion-dollar potato producer says, look, I want this thing. You just made the thing, and that was what it was. For ConnectAir, there's an opportunity to say, okay, if we change our checkout workflow, if we, change the color of a button, if we figure out what the customer really needed here, can we improve that process? And so for me, it was, taking my toolbox of software tools and saying, okay, how can we really use this to polish something neat for customers? And so, that was kind of my excitement jumping towards it, and using that, the background of all of the machine learning and machine vision and modeling of those kinds of things to make that possible.
But to some degree, you've always been very customer focused, and actually, I want to pull another anecdote out of the past, because I really like this, and this is a good lesson. Again, analytics is one thing, and managing AI is another. But actually understanding what the customer wants it very often ends up being a primary thing. And I'm actually recalling back in the honeycomb days, you were talking about, you had multi-terabyte images of farm fields that farmers could look at. Talk a little bit about what you discovered in terms of what you thought they would use it for versus how they were actually using it, and what that made you change.
Yeah, so this is a lesson I've learned on product management. And as an engineer, when I first started at Honeycomb, I had the vision in my head of all the things that we needed to go make. That, like, I had the vision of the product that we were supposed to make, right? And so built most of that out and had real customers up and using it. And then we started getting customer feedback from people, right? And so, there's opportunities to get better at things and opportunities to improve the product. And one of the ones that they kept asking for was, hey, can we have this? Can we have our images in the Google Earth format? So Google Earth is a modeling tool that lets you see the entire globe and do some real limited GIS kind of work on top of it. And so we thought, great, we have all the data, and we can add an extra line of another button to our UI. People can download these images, and that'll be, we'll serve the customer like this. And so put a little bit of work into it. Folks started downloading these images, and we thought, great, we nailed it. We did exactly what the customer asked for. And then we realized that people start downloading these images, the same image, over and over and over again. It's like, what's going on? That, like, why are people downloading these huge files, multiple times? And so do some more investigation, talk to some more customers, and start to figure out that these folks didn't name their files well. And so, a file named 12345 just got lost in the hard drive, right? And so rather than looking for it again, they would just download it again, because that was easier, easier to do it. And so, I thought, okay, we can solve this problem. So a little bit of more code. The files now download with a name and a date and some other things like that make them easier to find. And so I thought, okay, we totally solved the problem now. And then they keep doing it. Like, what is going on? That, like, why are people doing this? And so some more digging, some more phone calls, talking to more customers, and then really start to understand that the reason they're downloading in Google Earth in the first place is they want to have two fields side by side. And our user interface didn't do that. And so they knew that Google Earth could, and they said, hey, let us download some to Google Earth, and we can do this. That, like, they didn't explain what they needed. They made a real clear ask, an ask that we totally could serve, but it didn't solve their actual problem. And so for us as engineers, especially, getting that product management side of things right, and digging into, when they say, hey, can I have this in Google Earth? Say, okay, why, and ask why until they're annoyed, right? And until you really understand, hey, I need to compare these two fields, and your user interface doesn't do that for us. So, let's go do that instead, right? And so, that example for me is one where we did the right thing for the customer. We did exactly what they asked for, but it wasn't what they needed. And so figuring out how you get to that, to the actual customer need much quicker, that you're going to get asked for a red button or a wizard that does this thing. And so, dig into that and really understand, what the customer is trying to accomplish. And we haven't bumped into much of that with Honeycomb or with ConnectAir yet, but we absolutely will, right? Where we'll get customer feedback on something that says, hey, this part's confusing, or I really wish that it did something else. And we need to be smart enough to dig into that and say, okay, is this one customer who has this problem, or is it lots of customers who have this problem? And what need are they trying to fill? And the same thing goes for the way we build our user interface. So what problem are they trying to solve, and can they solve it all in one place? Do they have to jump back and forth between different pages? Do they have to have multiple windows open to compare things, and really understanding what they're trying to accomplish and make sure our user interface actually lets them accomplish that in clean and in organized ways.
So to some degree, and this goes back maybe to some of the data that you're potentially pulling in, you'll be looking as much as what your competitors or what the major airlines are charging for a similar route to make a decision on that, because it's very likely that you've got a customer looking at your stuff in one window and on the American Airlines site in the other window going, well, I don't know, it's $150 difference. And sometimes even based on customer, the AI will be able to make the decision. I bet if I drop that another $25, they'll say yes to me.
Right. Yeah. And it's both. We want to try not to compete with United on Portland to Seattle routes. So there's no way I can beat them.
Yeah, you'll lose
on price, right? And so what we want to do is compete on those parallel routes. So do Hillsborough to Painfield or Hillsborough to Everett. And so that's a route that lots of people want to do, but it turns out nobody actually wants to go to the Portland International Airport. Nobody actually wants to go to SeaTac, right? That like, I'm not going to SeaTac, I'm going to Seattle, or I'm going to Bothell, I'm going somewhere else that's nearby. And so for us, we can say, look, I know there's real demand from Portland to Seattle. People do that trip all the time. But where do people actually want to be? And not just trying to beat them on the, you go to Google or Kayak or wherever you're going to search for flights. We can put together all of these different routes. Since we're generating them in software, we can go to Google and say, okay, here's all of the routes from Hillsborough to Painfield, or Hillsborough to Bothell, or Hillsborough to Everett, or Hillsborough to Boeing Field, and all of those become unique URLs that Google can now index. So when somebody types in, "Hey, I need to go Hillsborough to Bothell," we show up as a route, right? That nobody else can be there for. That Alaska can't make that route because they don't fly there, and so they try the Portland to Seattle route, and absolutely they're going to capture that, right? That they can offer, I don't know, $25 tickets sometime, and we never will. And but what we can do is capture that real demand, again, through Google optimization and other search engines, where all of our URLs are custom built between the actual location and actual location. So when people do those searches, we're part of that search process for people.
Mm-hmm. So what you're effectively saying here, and I think this is really important again for everybody listening, is AI matters, but also the customer matters, and also what you want to do matters. And so really it's conceptualizing what you really are as a business. You're not necessarily an airline. You can pick different things, but if your goal is to fly an airline, that's one thing, but your goal is to move a person from A to B as efficiently as possible in a way that's going to encourage them to buy your service.
Yeah, and thinking about that through the entire dynamic of different customers, right? So there are people who want to fly by themselves, and we've got some 3 and 4 seat aircraft for that. There are folks who want to fly with their whole family, so there's some 8-seaters. There's folks who really do think about the environmental impact, and so working on the next generation of electric and hybrid with a couple of partners of ours, and so giving those options to people who can really tailor that experience to fit their bill. To imagine you're going to go camping at the Grand Canyon and you landed there in electric aviation. Like, it's smooth, it's quiet, you hike out into nature, and it's beautiful. And so giving that experience all the way through, with an electric aircraft, that's the way to go. Where if you got a bunch of people flying to into Seattle to go do some work and things like that, the electric definitely doesn't have the same premium on top of it, right? That definitely people think about the environmental impact, but it's not the same as stepping out into the Grand Canyon off an electric aviation aircraft, right? And so there's some really neat things there that using AI to again find the right customer for some of those, that find the person that really does feel that premium, who really does feel the impact from what they've done, and then thinking through the entire process, everything down to your ride share is scheduled. So that as your aircraft lands, their car pulls into the parking lot. And so, getting those things timed right, using machine learning to adjust the timing on that so that, your Lyft or Uber driver doesn't wait or isn't late. And so all of those things as part of experience gives us some really neat machine learning targets to to figure out how we create that experience that we all imagine we could have.
Mm-hmm. So I'm going to flip it in one more direction, because I think the one thing that we've talked a lot about how analytics can be used here, and we're trying to encourage everybody to use analytics. I want to make the statement that analytics can be used pretty much anywhere. Right? First of all, would you agree with that?
Yeah. It's there's a lot of places it could be used, and it's like I said before, it's hard to trust the machine, right? That as smart people, we've got that gut feeling that this is the way we should go, but it takes a certain kind of strength to let go and say, okay, here's what data actually says, rather than leading the witness into what you wanted to go do in the first place.
So let me lead you. Why don't you give me a couple of minutes? A couple of years ago, you did a very interesting adventure in deciding that you were going to do a 100-mile run. How did analytics play into that?
Yeah, so I was inspired through a friend to go out and watch the start of a 100-mile ultra marathon, and I'd been a runner through high school and college. And so, a long distance runner, but hadn't actually even done a marathon at that point. And so he basically said to me, "Hey, Ben, you want to go do this next year?" And I thought, yeah, why not? Like, I'm open for an adventure. And so set out to go train for it. And to succeed at a distance race like that, you have to be really careful not to beat your body up. So if you wear yourself out, you don't finish. If you trip and fall, you don't finish. If you get joint issues, again, tendon issues, things like that, you don't finish. And so you have to run in a way that doesn't beat your body up. And so being a good data person, I ran with pods in my shoes, data on my watch, heart rate data, and things like that, and really set out to collect all of the data that I needed to succeed at training for and actually running this race. And so through part of it, again, I've been a runner my whole life. And so I had a lot of habits about the way I ran, about the way I took strides, about the way I trained for things. And I had to take a step back from that and say, what is data telling me about the way I run? What is data telling me about my shoe choice and my pace choice and things like that? And so it was hard that, like, I actually changed the way I run, that actually changed the way I walk. And it makes a huge difference in that kind of 100-mile ultramarathon territory. But it's really hard to change the way you walk, to change the way you tie your shoes and things like that, right? And so for me, had to take that step back, had to take that, I guess, almost humility, right? To like say, look, I'm not running in the way that's the most successful. And so I have to change the way I'm running. And so, I collected a lot of data there to start that project, and then had to actually, practice what I preached, right? And really change the way I run.
So that comes to a completely different way of trusting the data, but that's a business lesson that comes in terms of sometimes the data is going to tell you need to do something different.
Yep.
And that can be very painful as a business. And I've seen that, I've seen you do that at Resson and at Honeycomb, but I would imagine that's going to happen at Connect as well, where you're actually going to get the data, but you're going to encourage your organization to have the courage of conviction that says the data is asking us to make this change, and we need therefore to make that change, right?
Yeah, and it's smart to get into like A/B testing kinds of things. So back to the running example with those pods in my shoes, they tracked basically 6 axes, right? So impact and motion and things like that. And so I had a real hard data on how much body impact I was getting from different shoes. So what I did, again, being a good data scientist, ran in like 6 different pairs of shoes, the exact same route, same pace, and compared the data to each other. I wasn't able to tell the difference between new shoes and old shoes, but I could tell the difference between different shoe models. And so, the running store people say, hey, you need to replace your shoe every, 300 miles or whatever it is. I can tell you for a fact, you can't tell the difference between shoes. They might smell different, but impact wise, unless your shoe's falling apart, it's still there. But I did find different shoes that had 50% more impact on my body than others did. And so, I stopped running in those shoes, even though they felt great. And so the same thing for ConnectAir, A/B testing things, right? So put out 2 variations of your user interface that's got, a red button and a blue button, and see what people click. That are, my hunch is that they're going to click the red button. Well, maybe that says the stoplight colors, people, don't want to click it because it's red. And so they click the blue button. But we wouldn't have known that because my hunch said one thing and data said something else. Same thing goes for, pop-up interactions to encourage user behavior. Does it have the impact you want, or are people annoyed and click out of it before they even read it? And so, A/B test these kinds of things and say, okay, my hunch says this and hard data says something else. We shut the project down and move on. And there's no hard feelings about it, right? That we have to try these things to really learn and grow. But we don't want to keep banging our head against the wall of something we know didn't work.
Yeah. So to that, here's what, in all the time that I've spent with you, and certainly in all the time that we've talked today, we have 3 lessons for the CTOs. And it was funny when we were looking at the slides, we noticed the formatting error and said, you know what, it's actually not a formatting error. If you're going to learn 3 lessons, these are the 3 important lessons, and they're all number 1. So first, information is without meaningful action isn't useful information. And that was kind of your honeycomb story. But what do you think about that?
Yeah, got to take a jab here at the salespeople who might put this together on purpose. But the action side of things connects that full circle, right? Of like all the data, all the analytics is great, and a lot of companies are sitting on mountains of data, but don't have that. Don't have the analytics to do something with it, or don't have the heart to actually trust it and really make decisions on it. And until you do, all that data collection, all of that effort is wasted effort. And so, really getting to the point where you're collecting data you can take action on, you do have the ability to interpret it and to do that analysis, and then the heart to actually live by what your data collection said.
And then I look at the second number 1 lesson. Knowing what you see is not enough. You need to know what to do with it. And that was kind of your Resson story of, again, I can look at this bug on the leaf, but it's a bug. What am I going to do with it? So how would you apply that into business and generic?
Yeah, it's both the expertise of understanding, like, here's what worked and here's what didn't. Be able to reliably predict that this action is going to drive this result. And so here are 3 actions I could take. Which one of these results is the best? And so that's, I think, partially a data collection. Part of it is previous analysis of existing, of past experiments that you've run, and really tracking that data. And again, being honest about what the results are. That I want to do it a certain way. I want to run a certain way because that's the way I've always run. But this way is more successful. And so, it takes a deep breath sometime to get to the point to understand, here's the action we should take because this is a result that we're going to drive out of it.
Now, this third one's a little more esoteric. Decisions are more based on the data you have when you need it, not on what data might otherwise make a good choice. And this, to me, I think is really the heart of analytics. And you talk about it a lot. And I think this is really the ConnectAir story. You need to make the decision because somebody's going to push a button or they're going to click off your site. And so you want them to make that decision. You've got to do it on the data you have at that time, not the data that you wish you had so that you could make a better decision. So talk a little bit about how that applies to practical business.
Yeah, going back to the precision agriculture side of it, if we're doing a smart sprayer, so as it drives through the field, it sees the bug, turns the sprayer on, and hits it. I only get 1 frame to get that bug right. So I have to look at it and say, okay, this is probably a bug, or it might be a piece of dirt on a leaf or something like that. But I have to make that decision in literally a split second so that the sprayer can come on. And the same thing applies to ConnectAir, where, like you said, somebody clicks on the website and they put together a flight that they'd like. In the background, I have to correctly price that flight before they see the prices on things. And so I have literally like a tenth of a second to get that calculation right, of looking at the weather, of looking at the dates and times, of looking at the other possibilities of return legs and things like that, to crunch all of that down into my actual cost of operation, and be right enough about it that I don't lose that game very often. And so, I don't have the weather 6 months in advance, but I can say it's going to be wintertime in Colorado, and so there's a 50% chance that it's going to be snowy there. And so, how do I factor it into things that I can't know whether exactly it's there, but probabilistically, I can make decisions about things I don't know exactly. So having that right blend of being able to jump back and forth between the concrete world of, I can see there's actually a flight delay at San Francisco right now, and that's an opportunity to capitalize on, versus there's probably going to be a snowstorm in Colorado this winter, and how do I act on those differently and act on them appropriately based on the data that I have now and the time I have to think about it, right? That split second before the customer sees that decision. So there's a lot of split second decisions you have to make that using probability can help interpret or help make sense of some of the things you can't know for certain. So you make good expected value calculations from it.
Yeah. Well, Ben, my friend, this as always is a fascinating conversation. And I certainly appreciate all of you who are viewing this webcast for joining us and listening into the conversation and submitting those questions. And we certainly want to thank you for viewing the webcast. There is a rate the webcast and provide feedback. Please do rate the webcast and provide us with feedback. We at SNIA use this in order to, first of all, pick new topics and also to understand how we should pursue these topics moving forward. A webcast and the copy of these slides will be available at the SNIA Educational Library, and you can see the link there. And probably within the next week or so, we'll have a Q&A from this webcast, and it will be posted to the SNIA Cloud blog, and you can see that as well. So follow us on Twitter. Follow, what's your KinectAir Twitter handle, Ben?
I think it's KinectAir. I think it's just straight KinectAir. I'd have to make sure though.
KinectAir MOUSE. And sorry, Disney, if I infringed on your copyright there. And for those of you out there that are wondering, well, hey, what can I do more to learn and participate? You can always join the CSTI. We meet regularly, we participate in regular collaboration, and we come up with great topics like finding a genius who's starting his own airline and really understanding how we can turn this into a lesson for everybody. So you're more than welcome to join and participate. We would like to thank you for joining this webcast. And Ben, again, thanks for the great conversation as always.
Yeah, thanks for having me out. It's always great to talk to you, Jim.
All right. Love to the wife and kid, and love to all of you out at the out listening today. And we will talk to you soon. Have a great day.